Uh, I hope you had a nice lunch, and let's move to our first presentation for the panel. If you're considering migration to .NET 6, we have a colleague who has a thrilling story of his journey. He has 16 years of experience and is for 4 years with us. He's a software developer and product owner. And yeah, let's hear from our colleague Bartłomiej Karwacki. Let's give him a warm welcome.
Thank you. Hello, everyone. I'm Bartek Karwacki, and today I would like to tell you a bit about how to approach and implement a migration of a large-scale monolithic system from Net Framework to Net 6. This presentation it's a real life story, so to speak, and I hope it will be tremendously useful for everyone who has currently the same dilemma, whether to migrate or not to migrate, and if migrate, how difficult it will be. So I hope this presentation may help everyone in this regard, and also prepare everyone for the problems along the way, because there will be problems definitely. So let's. Sorry. Right. So let's start. A few facts about me. I have currently some years of experience as primarily a Net Framework developer. So I was professionally interested in this matter also. And I was working mostly in financial and transportation area, customs, excise, and stuff like this with systems that communicate with whole European Union and other EU countries. And currently, for 4 years, I'm a consultant for KMD and Edlund, and helping them develop LifeLink, Scandinavia's leading start-up solution for policy administration and life and pension sector. Right. So let's start. A small introduction to Net Framework, what it is and why do we even have to consider migrate to its successor. Well, Net Framework is a software platform and a runtime execution environment made by Microsoft around 20 years ago. It gained a popularity, it's still popular. One of its programming languages, C#, is currently in the top 5 of most sought after programming languages. And from my perspective, it's the platform is easy to use, it's fun to use, and you can implement a rich client web service, mostly whatever you want it is. And right. However, this year it saw its last version, excluding some bug and security fixes, because Microsoft thought the current state of the framework is probably not future-proof enough, since it was not multi-platform, it was Windows only. So they started to develop its successor. And this successor would be first called Net Core, and then it was renamed to .NET. It saw its first version in 2014. And by definition, this successor of Net Framework is both cross-platform and open source. So in a world when we are using open source more and more, this was a good move from Microsoft. And obviously, everyone started to think whether we should move to this Net Framework successor, and how difficult it will be. Right, and about some more about versioning, because the versioning of this Net and Net Core changed a bit. In comparison with Net Framework, we have each odd number is a short-term release, and each even number is a long-term support release. So we will be discussing today moving to Net 6, which is a long-term release, which is supported for about 3 years. Right. So as I said, Net Framework is still supported, so it will have bug fixes, it will have security fixes, but no new functionality, which is not the case with .NET 6 and beyond. Right. So why migrate if it's still supported? Right. Your system works, everything's fine. You will have bug fixes, no new stuff though. So why migrate? Well, the customers may actually expect you to migrate, so they know you aren't staying behind technology-wise. Net 6 has new features, performance improvements. Also, since it's multi-platform by default, and it's maybe a prerequisite for you for going cloud. And also, your developers may simply expect that you are upgrading, moving with technology, so they have new fun stuff to work with. And that's exactly what happened on our side. So let's talk about this monolith we'll be migrating. And the monolith is called LifeLink. This is a life on pension system developed by Edlund. And it's quite a big system with mostly standard 3-layer architecture. We have the rich client made mostly in VPF and WinForms. We have some web service consumers, external and internal. The whole front and back-end communication is done via VCF. And we have online servers, which are mostly VCF services. Also, so there is some SOAP in the backend. We have service hosts, which host independent business processes. And we have Microsoft SQL Server in the backend. Right, so pretty monolithic, hard to break, and all of this is in NetFramework 4.8. Because we were, this is a long-running system, and we were upgrading along the way. So the code base consists of over 2,000 NetFramework projects. Most of it C#, some of them F#. Like I said, the presentation layer, the rich client, is VPF and mixed with WinForms. There is a business logic layer, the backend VCF, and SOAP services. And regarding VCF, which we'll be talking about in the broad scope today, we have about 600 VCF interfaces in shared code, and the contracts for those services are pretty complicated. For work, we have a custom batch process framework, we have SQL Server, and also some additions. We have custom code generators, we have customer-specific code, because us having multiple customers for the system means that each and every solution is actually a bit tailored to specific customer requirements. So, customer-specific code. And we also have some custom serialization. Right, so after the higher-ups gave us a green light for considering migration and analyzing it, we have to do, well, the top-level analysis to see how, if it's even feasible for our solution. So the first step was actually a tool developed by Microsoft. It's called the Net Portability Analyzer, which simply scans your assemblies and verifies whether they have problems. I mean, it presents those in the table that says, for example, this type is Net Standard compatible, or Net 6 compatible, or Net 5, and so on, and presents a report. This worked well, and it was pretty. The report is pretty detailed, but it's depending on the size of your solution, it can be huge, right? Because it analyzes all the types in your assemblies. Right, and so that was the first step, doing this report and trying to find the most important stuff. And the second thing we analyzed is the breaking changes page exposed by Microsoft on MSDN, which lists everything that's changed between Net Framework, Net Core, and Net 6. Remember, we are jumping straight from Net Framework to Net 6 and skipping Net Core and everything that happened during Net Core times. So yeah, so there is a huge list of changes. However, this breaking change is pretty lacking in many areas, as you will probably experience if you decide to migrate and try to learn directly from this. And after reading and running all this stuff, we have identified the main problem during our migration, which is VCF. Unfortunately, while Microsoft was always trying to preserve backward compatibility when creating and developing new versions of Net Framework, it is no longer the case when jumping from Net Framework to Net Core and beyond. What they did is they completely remove the server side of the VCF framework, since it was, well, could say it was Windows only. Strangely enough, they left the client side. However, since our entire communication depended on VCF, we have been presented with significant problem when Microsoft effectively stripped completely our way of communication between the client and the server. Right, and also since all our projects were CS projects mostly, then it meant that all projects needed conversion to .NET SDK format, and we'll be speaking about that in a minute. So there is no project and no place in a solution that wasn't touched by the migration. Right, and yeah, so around things that were removed by Microsoft, that we have server side, we have distributed transactions, also a major point depending on how your solution is developed. They have also removed web services tree, so you no longer have VSA, assertions, SOAP filters, and so on. There is no longer message security, I mean the message encryption. There are no app domains anymore. There is no data contract serializer. This also hit us well moderately. There is no longer system web UI, which was a set of classes for generating HTML. No, they have removed remoting, code access security, COM+, so on. There is also much minor stuff like threat abort no longer being supported, and so on. So yeah, this gray vert image may be a bit grim, but depending on how much of this stuff you're using, you may be presented with a significant amount of problems. Right, so after we knew all that, we started hacking, we started migrating, and we have thought out the following process, in which its first step was converting project files. And this step was actually, may not be intuitive, because we have decided not to try fixing everything at once, but to simply make everything build as fast as possible. So what I mean is, instead of removing and trying immediately migrate code that's no longer Net 6 compatible, we have simply either removed or commented out, so we can this way unblock more and more and more projects until everything builds, even if it doesn't work. This process made it possible for the most developer to work on the migration at once. Otherwise, it could be, for example, one project that blocks 2,000 other projects from being migrated. So first is project conversion. I'll talk about that broader in a minute. Then remove incompatible stuff until everything builds. But obviously remember to create some kind of tasks for those, so you don't forget to actually implement it again. Then reintroduce and fix after everything builds. Then make it setup. Obviously if your application has some kind of setup process, make it run. And then you have integration tests and unit tests, right? So make them work. And do full regression tests afterwards, because depending on how much Net framework only technologies you were using, you may actually end up touching every place of the system like we did with VCF. Now for the conversion tools we were using. The first was try-convert, also developed by Microsoft, if I remember correctly. It's a small command line tool for just running, for just applying on a folder, and it scanned and found the CS project files, and then try convert them to the new SDK format. It has some problems though. For example, we have generated code, and some of the CS project files in our solution import some other projects, and this tool, well, exploded from time to time when trying to read those projects. So we had to develop a try-convert runner, which implemented some pre-processing and post-processing before and after the try-convert was run. Right, and this was the first step when we immediately started to see some benefits from the migration. I mean, the new format, the SDK CS Pro format, is much smaller, because by default, all the files that lie in the folder tree with the CS project are by default included. So you no longer need to have CS project files when you have like 10,000 files included, and conflicts with CS projects also related to those includes also disappear. So this is one immediate benefit from migration: definitely cleaner project files. Also, you get to remove package configs files which are also no longer necessary. Yeah, so this is all well and good for your source control system. Right. We have also created a simple PowerShell script for conflicts while merging from network framework branches into net1s, because this will be necessary afterwards, as I will show. Yeah. So all of this unfortunately touches only CS project files. There are no automatic tools for migrating code, and even if Visual Studio tooling has some, we haven't used them due to the amount of custom code and code generators and so on. So those were made by hand, while the CS projects were mostly done automatically. Yeah. What I would also like to note is that we have, in this process, we have involved our customers from the early stage. We had the core migration team, internal migration team, and which implemented the first steps of the migration itself, and then created a guideline which told other developers for other modules in our company how to proceed with their work. So we have communicated with other dev teams after the initial steps were done, and also customer developers on the periodic migration forum with customers, which we stage every month or so. So we were pretty open about the whole process with our customers. Also on this migration forum, we invited them to share their experience with migrating their code, because, like I said, every solution is a bit tailored for specific customers. So we have customer-specific code in our solution. Right, and like I said, we also created, during all this process, we have created a migration guideline document, which we also published for our customers, so they have an easier time migrating. While the core team was about 10 people, if I remember correctly, then in summary, in our company, it was about 40 to 50 people total that were working on migration at some time. Right, so like I said before, the main problem with migration we identified was VCF. So, well, Microsoft removing the server side of VCF presents us with that dilemma. Should we try to preserve the existing communication layer, or maybe switch to something well? Actually, Microsoft recommends just switch to gRPC Bro. Well, not going to happen in our case, unfortunately, like I will present in a minute. And our main issues with VCF and trying to switch to something else was the sheer amount of interfaces. Like I said, going into hundreds. Necessity for SOAP support, because we have some external consumers and we can't just order them to switch to some other technology. And also preserving security level, because we definitely don't want to create a new version of our system for our customers when we say, well, this is Net 6, but its security is lower. This would definitely be bad. And yes, and ultimately we found out 3 possible implementations which were considered and analyzed: gRPC, open source high performance RPC framework; Core VCF, which is an open source port of server-side VCF. This is important, server-side; and Web API based communication, a simple custom solution which just uses REST-like protocol to send binaries over the wire and uses and is built upon a Web API. Well, and we tried to experimenting with all three approaches and seeing what those experiments will show. So gRPC showed the following: gRPC uses protocol buffers, and they do not support inheritance, but favor composition. However, in our solution, there are many instances of both inheritance and composition. However, simply the gRPC protocol design doesn't match our contracts well. And yeah, the performance of gRPC was indeed much better, or almost an order of magnitude better than VCF for small data, but more similar with larger data. Still, this was acceptable. And like the further test show, actually Web API was faster. Web API option. Yeah, and yeah, one of the most important things was that migrating to gRPC would actually require us to implement a new authentication scheme, because gRPC uses HTTP2 and it does not support Windows authentication, unfortunately. Yeah, and in our solution, but this is solution specific, so your mileage may vary, we don't actually use many things gRPC is designed to excel in, like streaming. So ultimately, the verdict was, after those, that switching from VCF to gRPC is not recommended. The next experiment was with Web API, so custom solution, Web API based, ASP.NET Core based, a transparent proxy using existing VCF contracts. It was actually very simple to implement, just like 1 day or so. Right, and surprisingly, this had the best performance out of 3, outperforming even gRPC. The problem is this didn't support SOAP, being completely custom and so on. And yeah, and all existing extensions implemented for VCF, so all those message inspectors, so on, would obviously didn't fit this custom solution, so they would have to be re-implemented somehow. And well, we have many of those. And also, one of the risks is that this is simply a completely custom and not battle-tested solution. And I leave it with a thought for now. And then we started experimenting with the open source core VCF. Actually, we found out pretty fast that this is being developed reasonably quickly, reaching 1.0 and beyond exactly during our migration project. And they even we have even opened a communication channel with them, and they have actually fixed some issues we have found. So we rest assured that if we take this library, if we integrate it into our project, it won't suddenly stop being developed, made by people from Microsoft, by people from Microsoft and Amazon. Yeah, it's great that it also has SOAP support. Actually, they have added it also during our project. API is mostly unchanged from original VCF, but they didn't yet implement some of the things that were in VCF, and it is unknown whether they will be implemented. Probably not. For example, some bindings like net-named pipe binding or web HTTP binding. This also runs on ASP.NET Core, which we understand will allow improvements to ASP.NET Core immediately benefit Core VCF. So if we get improvements to ASP.NET Core, for example, in Net 7, this should also work faster. Right, the greatest thing is that actually no changes to our 700 contracts or so are necessary, because this stuff is simply compatible. Unfortunately, Core VCF is a bit slower for small messages, but as the request size grew, so does the similarity in performance also grew. And since we have both small and large messages, we have decided it shouldn't prove an issue. Right, so the time came for final decision, and after much deliberation, we decided to use Core VCF because of known API. Developers know this API, they know VCF. Low adoption costs, open source, and SOAP support. And we have left the Web API-based solution as a backup in case we found some blockers with integration of Core VCF. Fortunately, we have encountered none so far. Yes, and now for the aftermath of migration. Immediately, we found some problems. Well, first thing first, we have found serialization-related crashes in many places. So completely random places in the system would suddenly explode when communicating over the wire due to, due to some of the types that were serializable in Net framework not being serializable anymore, like the type, like collection base, and so on, so on. Some of this is actually mentioned in breaking changes page on Microsoft, but some of them isn't. So some of those you'll unfortunately have to find by yourself. Then we have some culture issues with culture-sensitive code, because actually Net5 switched to NLS, or was it the other way around? Sorry, I forgot. I tend to mix those two. It was the default change in Net5. So, for example, if your code is culture-sensitive, you, for example, can encounter some things being sorted differently. Depending on your business logic, this may be a problem or may not be a problem. Yeah. The other thing is related to publishing or build itself, because applications are now built by default as DLL files instead of exe files. And yeah, and this means that, for example, your scripts will suddenly stop working if you don't switch the publication mode to exes. And also, if you have MSI installers and you want to have those DLLs instead of exe files, you will have a problem, because, for example, when we tried it, we were unable to make MSI recognize DLL as a file it needs to generate a shortcut for. So if you have MSIs, you will probably have issues. Or just switch to exes. And yes, and we have some difficulty of comparing communication performance on Net Framework versus Net 6, because those tests shown previously were pretty artificial. And yeah, and it would be for the best if you actually have some performance integration tests before you start migrating, so you gather some data and see the impact on your solution. There were also some issues with VSDL files generated by Core VCF. Yeah, and this was a bit surprising. The more tests you have, well, maybe not surprising, but obvious, but you may be surprised when actually going to this stage. If you have many tests, then you'll spend much time fixing those tests if they had some code that's problematic after migration. If your integration tests go into thousands, then you may be surprised how much time it takes to fix them instead of actually fixing the solution itself. Yeah, and a good suggestion was to actually, whenever you find a problem and fix it related to migration itself, please put it into your guidelines so everyone benefits instead of trying to kick the open door again. Yeah, and one of the major problems found afterwards was the lack of MSDTC, or the distributed transaction coordination, which was present in Net Framework, but unfortunately no longer in Net 5 or 6 or Net Core. So what is this? This distributed transaction coordinator made possible for you to, for example, have a transaction that touches multiple either databases or, for example, some communication queue or stuff like this. So if you, for example, on a Net Framework code have a transaction that commits after two databases, so only after both communications are completed, then the whole transaction is committed, this no longer works and will simply throw an exception. If you absolutely need distributed transactions, then you may have a blocker, because this really has no workarounds. It's the amount of code that was in the Net Framework that supported this was so huge and complicated that, well, simply it's undoable doing it by yourself. So unless you reconstruct this business code, it's a blocker. Fortunately, Microsoft has brought the Windows-only MSDTC back in Net 7. However, this may be a problem depending on this time on your contracts with your customer, because Net 7, like I said before, it's an odd-numbered release. It's a short-term support. So if you switch to Net 7, you may find out that you very quickly have to migrate to Net 8 because of short-term support. And for example, your deal with your customer may say that your system must be always on a supported version of .NET. So this was a bit ugly when we switched to Net 6 and we found out that it doesn't contain MSDTC, since we want to remain on Net 6 for now due to it being LTS or long-term support. But yeah, so please, before you switch, find out the use cases of AMSDTC if there are any, and consider whether how much of a problem this is. Yeah, and going back to VCF. Just to summarize, well, it works. It works fine. We haven't had many problems. However, the issue is now that core VCF is server-side only, and the thing that Microsoft left in Net 6, the parts of the VCF are client only. So now we have two VCFs, the one for client side and the one for server side, and they need to coexist. So so it would be best if your code was split into client and server side, because otherwise you will have name clashes, because obviously the namespaces are different. However, all the types are called almost all the types are called the same. So you should definitely have specific stuff for client side and specific side for server side. They do work, they do integrate. But for example, if you have previously implemented some VCF interfaces which worked for both client and server side, then you have a problem, because you either need to split those or implement both interfaces from core VCF and like the standard VCF, and this becomes quite ugly, because you have like the same code twice, which operates on different types. Right, so once again, core VCF for server, classic or built-in VCF for client side, and assemblies containing shared contracts if you have those. Fortunately, those can remain with the standard VCF. And you have now, for VCF, you have now the new NuGet packages, system service model HTTP, system service model blah 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 for the current VCF, for the Microsoft VCF, and core VCF and corresponding core VCF primitives, core VCF, and so on for the core VCF NuGet. Right. And now for the benefits we observed, we have actually observed performance improvements in our system without doing anything. So this 10% to 20% in different places, like some calculations or or business code processing, we get those improvements without doing anything specifically destined to increase this performance. So this is just the result of migration and switching to Net 6. So depending on how performance sensitive your application may be, you can, if you're lucky, because obviously your mileage may vary, you can observe, for example, you can observe 20% performance improvements. And yes, and Microsoft says there are many more performance improvements arriving in Net 7. Yeah, just the small problem, it's a short-term release, short-term support. Yeah, like I said before, much cleaner project files. This is really great from the source control perspective. Support for new versions of Net languages, because Net framework won't get those, unfortunately. You get the new tooling, like .NET dump for collecting memory dumps, and so on and so on. And this tooling is also extendable. And you get happier developers that they move to new technologies. But right, when you migrate, and depending on the size of your system, well, it's hard to imagine that the rest of company would simply wait for you until you migrate the whole project. In our case, it took about a year. So while you're migrating, the rest of the company is probably developing new functionality. And well, how to do it? It's possible. First, if you are a developer, have to separate clones, because if you have, for example, if you had one Git clone locally, and you were to switch between Net framework and Net 6 once, then those intermediate build files would be a problem, and you would get from time to time strange build errors. Best to have two separate clones. And well, merge regularly. I know how you all love mergers, probably not too much, but it's better to merge regularly from Net framework code, from the branch you are developing new functionality into the Net 6 branch, because otherwise you would be left with a huge amount of changes accumulated, for example, over a year, and you will have to deal with that at once, so this can get ugly. And this would also make your other developers used to not introduce changes not Net 6 compatible. And obviously also have your test pipelines ready ASAP. So the code you're migrating is being tested as soon as possible to find out if anyone is actually breaking anything. Right, I think that was the most important stuff. Thank you for watching. If you have any questions, I'd be happy to answer those after the presentation. Thank you.
Thank you, Bartek, for this comprehensive show of how your migration experience went. Before we move to the next presentation, I would like to remind you that there are bags on the back of every chair. There should be one for each participant. There's some merchandise inside, so treat yourself. And now it's time for our second speech for this track. It's about Azure functions. You will learn about the serverless and how to run Azure functions. Our presenter has 10 years of experience as a .NET consultant. He enjoys building great software and local craft beer, not necessarily at the same time. Let's give a warm welcome to Michał Kubiak.
Okay. I want to tell you about Azure Functions. It's a serverless platform. Let's just start by decomposing like each part of this. What does it mean? So let's start by. Let's start by decomposing what is the Azure Cloud. So Azure Cloud, it's a kind of a service that Microsoft gives you. It enables you to get different kinds of service like runtime or servers or network infrastructure in like almost infinite amount in terms of like memory or usage. Of course, you know, as long as your wallet is also infinite. Okay, let's just go into more details. Okay, in this picture you have from the left you have the typical, you know, your server in your server room, and you have to manage everything from the computers, network, storage, machines, operating systems. You have to take care of everything by yourself. But when you go to the cloud, then you have infrastructure as a service, where the cloud provider here, Microsoft, they take care about the computers, networking, storage. They run where somewhere very protected data center, and you don't have to worry about this. You just get a virtual machine. But you still have to maintain the virtual machine, the operating system. You have to update the runtime. Then you deploy your app, and of course, then you manage the data and access to this application. So it's still a lot of work, but much less than on premise. Okay, the third row column here this is what we call basically the serverless. You just go to your cloud provider and you say, okay, Microsoft, I want to run an app in, for example, .NET 6. And they give you everything, the runtime, the operating system, the machines, the servers. It's all managed by Microsoft. In fact, you don't even see that there are servers behind it. So that's why it's called serverless. And the last option is like when you have software as a service. It means basically that when you just want to pay for usage of some applications. I will show you just a couple of examples now. Okay, so for For infrastructure as a service, the typical example is, of course, a virtual machine. And for SaaS, it's, of course, software that we all know and love, Azure DevOps or Office 365. And for platform as a service, you can have many examples. But for instance, you have web apps. It's, for example, an ASP.NET Core app running in the cloud, or you have mobile apps. It's like a backend for your mobile application. You have logic apps, which is like no-code solution. So you can just click around in the portal and define how the app application works without, or some processing of some data works without writing a single line of code. And then, you know, for code solutions, you have web jobs and Azure functions. So what are the differences between those two? In terms of web jobs, it's just a code that's running in the cloud. You can just run any code, and you can just then define how do you want it to run. Do you want it to run continuously all the time, or like on a scheduled basis? And it's just a basic solution that doesn't give you any nice interesting advantages. On the other hand, Azure Functions is also the code that's running in the cloud, but it's more flexible. You know, you can write functions in not only in C# and .NET languages, but also JavaScript, PowerShell, Python, Bash, and even PHP. The other nice thing is that it can integrate very easily with Microsoft and third-party solutions. There are already built-in integrations, and you can easily connect your functions to third-party data sources. And it has a simple billing model, which is based on the usage. You know, the unit is gigabyte or seconds, so it's memory usage in gigabytes times the seconds the function runs. And as you can see, in the basic plan, you have 1 million free executions and 400,000 gigabytes a second. I think it's more than enough, so you can develop your functions and run them in the cloud, fully test them to make sure that they run, and you will still have a lot of resources for free left, you know, to run them in production before you even spend your first dollar. Okay, now let's go into more details. What are some of the things that applications that are functions used for? So first of all, moving a piece of your code from application straight to the cloud. They have very easy entry points, so you can start by that. You can use them for processing of data on a scheduled basis, processing events from queues, processing data from IoT devices, sensors. You can use it for running a serverless backend of your application, because you can create functions that act like API endpoints, basically, for data streaming or conversation bots. Okay, now let's go into some more technical details. I will tell you how to build your first function and how to run them. So to develop your function, you need just any code editor, for instance, Visual Studio and Visual Studio Code, and you need also the Azure Functions Tool SDK, and also a nice addition is the Azure Storage Emulator. It's a tool because the functions need Azure Storage to run, and if you use Storage Emulator, you don't have to pay for Azure Storage when you're running your functions. So basically, you can do two things if you want to create your function. First of all, if you have latest version of Visual Studio, you can just use File New Project, or if you have Visual Studio Code, you can use the function SDK. And there are just three basic commands that you need to remember to start. You have the func init. It's the command that creates the basic structure of your function project. And then you have func new to add the function to your project. And then you have func host to run your project in the emulator on your local system. So then you can test your code, see how it runs. Okay, so when you create a function using this func new command, okay, you end up with something like this. So you can see that it's just a basic static class in C# with some and the basic method, and yeah. So the only thing that differs here is some special attributes that are added. So func name is, I think it's pretty obvious. It's the attribute that defines the function name. And the second one is the trigger. It defines how the function is launched. And I will tell you a little bit about this in a second. Okay, and the triggers mechanism is a mechanism that defines how your function is called, because your function is sitting there in the cloud, and if you don't define any triggers, there won't be any way to launch your code. Okay, so the basic triggers are, for example, schedule trigger. It defines that your function runs on a schedule. For example, I know every hour, every 5 minutes, every month. It's good for when you, for example, want to perform some maintenance of your system. You have HTTP trigger, which makes your function just an API endpoint, so you can call it by doing HTTP request to a particular URL. Or other one is blob storage, which causes your function to run when that data is added, when blob is added to your Azure storage account container, or like Event Hub. It's the same thing, but when event is added to your Event Hub or Azure storage queue, it's your function is launched when a message is added to a queue on Azure. The similar situation here is for Azure Service Bus queues and topics. Your function watches a particular Azure Service queue and reacts to it. Okay, so we now have one thing. So we know how to launch the function. But what if you want to get some data to a function? Okay. Or we want to save some data that is processed by a function, because the Azure functions by themselves are stateless. They cannot, like, by themselves save data, or you cannot restore some data that was processed by a function. Okay. But we can use a mechanism called bindings to solve this problem. It's a mechanism that allows your functions to connect to some data storage or like some external services in a simple declarative way. Okay, you have and you have basically two types of bindings. You have input data bindings, which is used where you want to get some data from external data stores into your function. Or you have output data binding. So when you have processed some processed some data in your function, and you want to save this data to some external data source, or send it somewhere else. And the nice thing with these bindings is that you have already bindings to a lot of Microsoft services in Azure, or like external services such as Twilio or SendGrid. and you can very easily this way connect to some services and do your data processing. Here you have another example of a cloud Azure function, and this function writes to table storage. And as you can see, it's also triggered by a HTTP trigger, but it writes to table storage this time. As you can see, all we need to do is we need to populate these values, the partition key, the row key, and the value that you want to save here. And in the declaration of the function, you have to have an attribute to which table do you want to write to. So it's very, very, very easy instead of having a more cumbersome solution. When normally you need to connect to Azure storage and then get a table storage client and then use this client to write to table storage. Here you just need to use these attributes. And there is a similar mechanism that goes for other that works for other bindings. Okay. So now that we have the basis of the functions, how to write them, there is the second case. What if something goes wrong? Okay. Here we have two possibilities. If you want to, functions are in this core. It's like a .NET application. So if you have your functions project in Visual Studio, or you can easily just debug it by using Visual Studio debugger, like just press F5, start with debugging, and the function will start in debug mode, and you can create your breakpoints and see how it works there. You can also write unit tests and call the functions like manually, like any other function you would, and you can check how your function is running also. But what if you want to have what if something goes wrong after you deploy your function to the cloud? So you have the second case here. You could use the Cloud Explorer, and it's a tool inside Visual Studio. You can connect, as you can see, you can connect to your Azure subscription. And in this tree, you have all of your service instances that you have created in your Azure subscription. And in this tree, you have to find the function that you want to debug, and then you can just right-click and click Attach Debugger, and you will be able to debug your function this way. Just call your function like normally, or using the portal or any other ways. And if you press the breakpoint in Visual Studio, this way you will see the function stop, and you can check what is happening. Okay. Now let me tell you about deployment. And here you have couple of steps. Of course, like with any other web projects, you could use Visual Studio Publish. You just can publish from Visual Studio by just connecting to your Azure subscription and clicking Publish. But it's very cumbersome because you have to then remember to click Publish after making a code change, and it's and you have to remember to do something, or you will not see the change. So this was one thing that's very wrong about it. Or like a more but this is nice for just one of time deployment. But if you really want to move with your application, you should use continuous integration. And to do it, you have couple of options. You could first of all, you can create a pipeline in Azure DevOps, deploy functions. It's already built into Azure DevOps pipelines. And second of all, you have a nice integration in the Azure portal. Here you have, if your functions, you have a deployment center tab, and you can connect your function up to a repo in either, as you can see, Azure DevOps, GitHub, or Bitbucket, or like any other Git server, and you can tell it to deploy a new version of your application. For example, whenever the branch, the main branch is updated, and this way you will have on your Azure instance, you will have always the latest version of your function application. Okay, but of course, like nothing is perfect. This solution has also some disadvantages that we have to always consider whenever we are choosing a solution. For example, there are memory and time limitations. For the basic plan, you have a limit of 1.5 gigabytes, and if you extend this limit, if you don't fit in with this limit, your function will be killed. No, and if you have also time limit. So if your function runs then for more than 5 minutes, it will be killed also. And moreover, for basic plan, you have also the cold start delay, which can be a problem because, like, when your function sits and does nothing, it goes to sleep. So before you are able to call it, you have to wait for a little bit, like maybe 10 seconds to 20 seconds, for it to wake up, to spin up the underlying app services and VMs, and then there is like a delay, so it's not entirely fluent. Okay, but yeah. So you have to take this into consideration. But if you go with the premium plan right now, this is not a problem. And also, with other distributed solutions, if you have if you debug one function, that should be pretty easy. But if you have a complex chain of functions, like one function saves to the queue, then the other function takes the message from the queue, does something else, and the third function does something with the result of the second function, it might prove to be difficult to find an issue in such a complex scenario like that. And the last thing is vendor lock-in. So the code that you write for Azure Functions will only work with the runtime that is in Azure Cloud. I mean, other cloud providers, from what I know, also have this kind of solution. For example, Amazon has, I think it's called Amazon Lambda, but the code is a bit different. So you cannot just take your application and go from Azure Cloud to Amazon. You will have to rewrite your solution again if you want to switch cloud. So you are pretty much locked in there. Yeah. So this is what I wanted to say. Do you have some time for questions? Or?
Yes, we have 5 minutes.
Okay. Anybody have any questions? Yes.
Have you used this in a product so far?
Yes. Yes. I worked for a startup in the UK, and they did processing of the client's data from different services, and this Azure Functions enabled you to just in the app define some like joins, like like, you were able to like take for example, customers from this service that are not in this other service, and then for the customers that remain, do some action. For example, send the email to customers that have bought, for example, 5 products, in the last month, and you were able to build some marketing flows this way. Yeah, but this solution used actually some sort of advanced topic. It was called orchestrating functions. So you would be able to build like a flows. You would build like a function that creates other functions, and creates and would run different functions depend on the flow of the logic of your application. It's a much advanced topic, but this makes it, I think, more powerful.
Okay.
Any other? Okay.
Thank you, Michał. Thank you for the comprehensive explanation of what the Azure functions are and how to run them. So right now we have 10 minutes till the next presentation. 5, okay, 5. So let's meet in the room in 5. Okay, so it's time for our next speech. It will be CTO Office 360 assessment of products. If you'd ever need to send a rocket into space, these two guys would be your best match. Tommy Anderson, our senior solution architect with 20 years of experience, he would write the software, no matter what language that would be. And Martin Lita-Ciborowski, our principal development advisor, he would come up with all of the advices that you need, all of the metrics, all of the charts to make your mission critical objectives met.
Wow, thank you.
Yeah.
All
Okay,
right.
guys.
Well,
I'll
thank
pass,
you.
Stage to you.
Thanks. So my name is Martin Ciborowski, and this is Tommy, my colleague from the CTO office, and I'm not alone. A lot of people from the CTO office joining us today. That's really awesome. I actually know that there's around 60 people online as well. So welcome to you as well. Oh, we have the clicker. Let's hit it off. We only have 30 minutes, and there's a lot to cover. We might not cover everything, but let's start by just making a brief introduction what this meant by an assessment. So in KMD, there's a lot of product, and if you work in a product for a couple of years, you find out that there's lots of things that are not working, and you try to spend all your time fixing stuff that is broke, right? And at one point, you might have the question, why are we still fixing these things? Why is this not working? Maybe we're doing something wrong. It would be nice if somebody from the outside could just have a look and just give us their opinion, right? And that's actually what the CTO Office's 360 is about, is just give an honest opinion about all the aspects there is in product and come up with some ideas that could direct the product in an improvement, right? Normally we use this analogy that when you come to the doctor can ask you all kinds of questions. There's probably nothing to do with why you're there. They'll ask like, are you getting enough sleep? What are you eating? Do you have your exercise? Do you smoke? Do you drink? All these things, right? And that's just to get a good idea of what could be the issue. How much coffee do you drink, for example, right? So these 6 areas is some of the questions we could ask a product. Some of it is obviously about quality of code, something about employee experience, something about agile and metrics, the way you work, some financial numbers, profitability, some technology choices, and of course, how do we deploy and release. And today, we're not going to cover all of them. I have to remember this one. We're going to talk about these 2. But before we do that, I want to talk about the elephant in the room, because none of you will probably like to be assessed. So this is actually some of the points that we had last time we visited a product. We had a lot of assumptions of how the product would actually react to having an assessment. The assumption was, of course, that we would find a lot of technical debt, right? We would also have the assumption that there would be no general test strategy and no test automation. There would also be this mindset of no willingness to change. It's always been like this, so why change? And a bit of hostility toward us in the CTO office, right? And what we found out when you actually go out and meet people, you do the clicking, is there was actually no significant depth. This was actually quite a surprise to everybody, because working in a product that is 20 years old, there must be some kind of depth, and of course there is, but not to the extent that we thought. There is a well-defined test strategy, and they actually did deploy a lot. However, the unit test was lacking. Next. Everybody recognized the challenge, and they were actually very eager to share and to do some changes. And lastly, everyone has been very open and friendly to us, right? So I think it's important that when we do assessment, we remind ourselves that people generally don't like assessment, or there's some kind of fear attached. So recognizing this up front is always good. But let's dive into the actual assessment.
Yeah. So since this is a tech summit, we thought about going into quality of code, as this is probably the most tech-savvy thing we have. Obviously, we also look at the architecture, but for now, let's look at the quality of code and what we mean by quality of code, because code quality is a heavily subjective subject. So we try to take that subject and turn it into something more objective, something measurable. So when we talk about quality of code or code quality, we have different parameters that we look at. The first one, size, doesn't really have anything to do with quality, so that's a good start. But it is a good measure that we can actually use in some of the other parameters that we look at. We look at code churn, which is basically how many changes are happening to the code base. How often do we have to modify files that we have committed? We look at technical debt ratio, which Martin just briefly mentioned that we didn't really see any significant amount of. We look at test coverage. We look at testability of the code. So how well is the code written to be tested? We look at complexity of the code. So how readable is the code? Of course, we dive into which languages are used. That's also basically to get an understanding of what competences are needed and required. And we look at the architectures that basically tells us something about how scalable the solution is. I have to apologize for my voice. I have a bit of a cold, so that's why my voice is a bit rash. So the first thing we're going to look at is the test coverage. And basically, this probably doesn't come as a surprise to anyone, but we want the majority of the test to be around the lower end of the test pyramid, which is the unit test, which is the tests that are actually closest to the code. So we want small, isolated tests that can be triggered rapidly. And the thing about the test pyramid is that the lower you are in the pyramid, the cheaper it is to write the tests and run the tests. And one of the reasons why it's so efficient to have tests in the lower end of the pyramid is that the feedback loop is shorter, which means that you will often have a shorter time from creating the change to actually getting a feedback of whether the test has run and whether it's successful. So as much as possible, we want the test to exist in this lower case. The first assessment that we did had a lot of unit tests and actually pretty good, a lot of tests and actually pretty good tests, but they were all in a sort of exploratory domain, which means that running the test is expensive and time consuming, and which means that from the developer creates a change to actually sees the result of the change, it takes a long time. So for the mindset of the developer, you create the change and you have to wait perhaps 2 weeks, 3 weeks, 4 weeks to get feedback from it. Your mindset has shifted and you're already thinking about something else and another problem that they're trying to solve. So as much of our test as possible, we want in the lowest bracket. Another thing that we're looking at is how much of the code is actually covered by unit tests. And ideally we say we prefer something around 80%. That's an 80% coverage and an 80% line coverage. So 80% of the lines are covered by test. And that's just a metric that we put. Honestly speaking, it doesn't really matter if it's 70 or 90%. The important part is that you have a positive trend. So we would much rather see a low coverage but a rising trend than a high coverage and a falling trend. One of the reasons being that with a high coverage but a falling trend, it appears that new code is not covered by test, which means that test has not been a focus point, and that means that all new functionality is expected to have a lower quality. Instead, if we have a rising trend, it means that new code is expected to have tests covered, and that means that test is an essential part of the design of the code. So we prefer a rising trend over a falling trend, no surprise there. But even over a high coverage, we want to see a rising trend. And the reason why I said that doesn't really matter whether it's 70 or 80 or 9%, it's because once you reach those numbers, you have a sufficiently effective testing strategy. As long as you have a rising trend, it doesn't really matter. There might be customer contracts that require you to reach a certain amount, but that's a different topic. Yeah, this is in.
So we both have something with our voices today. So that's why I'm do some crawling, swimming, I guess, backstrokes. And now Tommy is ready. Go.
Yeah, so we really enjoyed the Polish weather. Thank you. So the first thing that we can measure, and these are all objective measures, we follow a very well-defined protocol for how to calculate these scores. So the first thing is the cyclomatic complexity, and cyclomatic complexity really tells you something about how testable the code is. So you look at a piece of code, and you can actually get a metric back that tells you, well, how easy is it to write a unit test for this code? So the cyclomatic complexity tells you how many linear paths are there through this code. And it'll give you, for a function, some value, and this is basically our interpretation. We want you to ideally be in between 1 to 10. It's not possible always to have a 1. I mean, that'll never happen, but from time to time you can end down there. But ideally we want you to be in the range of 1 to 10. That means that your functions are well isolated and easily testable. But one thing is testability. That doesn't actually mean that the code is readable. For that we have something called cognitive complexity. And cognitive complexity tells you something about, if I as a reader looked at the code, how easily can I understand it? And understanding is important because we write code, but as products live on for 20 years or perhaps even more, it is very likely that someone else will look at our code and make changes to our code. So cognitive complexity tells us a bit about something about how easily can I look at someone else's code and read it and understand it. So with cyclomatic complexity, we can focus on unit tests. That tends to have a positive effect on the cyclomatic complexity because you are forced to sort of reconsider how can you make your code more testable when you have to write tests for them. With cognitive complexity, it helps to have an extra set of eyes on it, pair programming, thorough code review, and etc. With cognitive complexity, we would like to see a number that is at most 15. And again, these are numbers that we have chosen. If they had been 20 and 30 here, it wouldn't mean that much, but it's just to have a sort of a baseline that we're aiming for. So one of the next things that we are looking at is something called technical debt. And basically, whenever you add a line of code, you're adding technical debt to your product. So technical debt is completely, you can't avoid technical debt at all. So, and since technical debt scales with the number of lines of code, we are looking at something called the technical debt ratio instead of the actual technical debt. And the technical debt ratio is the amount of technical debt you have, which is measured in time, versus the cost of rewriting the solution.
Is this where I come with a question? So how do you actually... oh, wow. You come prepared.
Yeah. So technical debt is something that we get from a tool called SonarCube. You could use any other tool. Basically, it sums up the amount of code smells that you have in your code and adds a penalty or a cost to that. But the cost of rewriting a product, how costly is that? Well, if we're using SonarCube, it actually says that a single line of code takes 0.06 days to write. And that is, with a quick... That's around 16 lines of code per day on an 8-hour day. And most people will look at that and say, okay, I'm a lot more efficient than 16 or 17 lines of code per day. And then that is where you have to stop and say, really? So the Mythical Man Month actually states that a seasoned developer will write 10 lines of code per day. There are other studies lying in the around of 20 to 30 lines of code per day. But that is basically what you can expect. And if you go beyond 16, 20, 30 lines of code, you'll probably end up adding more technical debt anyway than you're fixing. So we're calculating with 0.06 lines of code per day. And it doesn't really matter that much as long as the baseline is the same in the entire way through. So for the last assessment that we did, I've extracted the numbers that we used. So we had 122,600 minutes of technical debt in that project. And that sounds like a lot until you consider that it had 743,957 lines of code times the cost of developing a line of code. It ends up being 21,425,000 something minutes to actually rewrite the code. And in that context, the technical debt ratio is less than a percentage. And for technical debt ratio, we prefer or advise that it is below 5%. So this is extremely low. I've actually never seen a number that low before, which came as a surprise to us, but it actually came as a surprise to the product as well. They were shocked, which is actually a fun thing. So the last thing about code quality that we're going to look at here is to focus on, well, when you do have to rewrite parts of your product, where do you want to focus? So one way to look at that is to look at the churn of the code. That is, which parts of the code are changing most often, most frequently. So if we have many changes, we are in the right side of the diagram with a lot of churn. And then look at complexity compared to that. So if we have many changes in areas of the code that has a high complexity, then that is probably the area that we want to focus on rewriting. And that is some of the guidelines that we can assist with. So we can look, where do you have a lot of changes? Where do you have a lot of complexity? Which part of the code base of the product is not testable? So this might be where you want to focus your effort. Yes.
Awesome. Next part that we can cover. Well, how much time do we have? 8 minutes, right? Yeah. All right. Okay. So release and deploy, probably the most hard exercise any product will face, is actually shipping it to the customer. Oh, need the clicker. So this actually came out of as a tangent of the original assessment, but we found out that this obviously needs to be part of the 360 assessment. How do you deploy, right? 14. 13 minutes. All right, perfect. So one way of asking questions about versions is you have this diagram. So down here you have like versions, and on the y-axis you have customers. So if your product looks something like this, you'll have around 12 versions of the product in production, right? And with a total of, let's say, 50 customers, you will spend a lot of time updating and moving stuff around. So this is an example, but the yellow bars are hot fixes. So for those of you who are actually intimate with releases, normally you would have like one release, and if you had any changes to it, you would hotfix those changes immediately, right? But as you progress and you add more and more versions into the production and customer starts testing it, you'll find bugs on old versions, right? And here's the dilemma. Do we fix that version? But what about the versions in front of it? Should they also have that fix? And these new versions probably had new code. So all of a sudden, everything that Tommy talked about, tests, right? The high-level test, you begin to be extremely dependent on the unit test, right? So this is an area that we have a lot of talk about in the 360 assessment. And from your own point of view, having one version in production is extremely efficient, but not always easy to get there. So number of version in production is important. All right. So another thing is to understand is it also takes time to deploy production versions to production. Some might think that it takes just with the click of a button and everything is in production. Some areas you need to have like a couple of weeks of preparation just to update the customer to that version. Usually you actually ask the customer that you're going to introduce this new functionality and they would like to test it. So they'll test it for a couple of weeks, and if they don't find any errors, you might do an update. After you've done the update, you want to do hypercare if there are any errors, right? In this case, which is not unnormal to see, here you have a product. It has a version coming out every quarter. So let me just quickly go through the diagram here. So every column here is a month. The number of customers that this product can upgrade is 5, right? So, and we spend roughly 3 months creating one version. So when the team starts building version 33.01, we start upgrading customers, 5 a month, right? After 3 months, new versions come out, right? So we start upgrading new customers with the new version. The old version is still there, 3 months later, and so forth. Which means by design, you always have 4 to 5 running versions. So it's not just about reducing the amount of version, it's also understanding how long does it take to actually upgrade. Yeah.
Yeah. So I guess that's basically it. I mean,
Yeah.
we might have time for some questions, I guess. We have like, what, 5 minutes?
10. All right, perfect.
Okay, so I have one question. You went through 2 of the 6 criteria that you mentioned in the beginning. Are you planning to give us an introduction to the remaining ones in any future?
Yeah, we can go back to the beginning. Let's see if there's anybody specifically.
Here you go.
Yep.
Yeah, well, some of them are metrics that we do not really, as the 2 of us, have an opinion about. I mean, we do not dive into employee experience here or profitability. So obviously we're going to spend time on that. But that is part of the 360 assessment.
Yeah, I can actually tell. So normally we would actually go to the HR department together with management and pull out like employee engagement surveys. We'll look at developer satisfaction, retention rate, how is the actual situation with the employees? Are we looking into Polish-Danish setup or Bangalore, Poland, Denmark, right? What is the age? All these things, just to get an idea of like what kind of product are we talking about, right? So that would be one part of it. Another part would be profitability, would be like how many, how is the margins really for this product, right? How is the revenue, how is the EBITDA, how does the customer see the product? Do we have a trend? Is the Net Promoter Score rising or falling, right? These are things that you want to consider. And obviously, once you have all these things, you can start to do some correlations, right? For example, customers that have many versions out there, they will probably experience that it takes long to get a specific feature, right? Because they need to either upgrade or the entire development organization is busy creating new features or fixing hot fixes, stuff like that. Technology choices. Actually, we can talk about that.
Yeah, I can mention a few things about that. So, so we look at the technology choices and the architecture that have been put into the product, and see, okay, how close is this to be scalable? So, for instance, can we add extra nodes? Can we? Is it something that is actually capable of being moved into the cloud, or is it locked to some different, some specific vendor? Does it use Azure Functions, for instance, and is being locked to Azure? Is it using a specific database system that is particularly difficult to migrate to other systems? Is it a microservice architecture, and can we therefore take any of our services and replace with something else, for instance? Is it containerized, and do we get the benefit of that, not only in deployment-wise, but also when reproducing a production-like environment for the developer? And for the last assessment we did, we actually spent a lot of time trying to understand how the containerization of the product was. And that was a journey that was ongoing. Obviously not complete yet, but that was ongoing. So we also look at what is the plan. So this is the technology stack that you have now. What is the future plan for it, and how does it support that? Are you considering moving into new markets, and will the technology that you're using still support that? Are the technology you're using based on deprecated frameworks, languages that are specifically difficult to find talent for? Yeah, that's basically it.
Yeah. Agile and metrics. I just want to make a quick comment on that. So, vast majority of development teams today are using some kind of agile methodology. You'll probably see teams organized with product owner or scrum master. They'll have a backlog. They'll all have some kind of sprint, and obviously we can have an opinion about that. Often Scrum teams will have you'll never see Scrum team that think they're doing awesome. They'll always be struggling with something. If they're really good, you'll find out that what they're struggling with is extremely specific. That's also a very good sign. But in this case, a team that is working agile and metric but have a deployment strategy with so many versions of the product will struggle no matter what, right? So yes, we could try to improve some of the things, but unless the product changes its strategy regarding versions, not much is going to change. So you would not get any bang for the buck of the time spent there, right? So that's one example of how you can do the 360.
And I guess an important note on that is that, yes, we try to identify the bottlenecks, the real bottlenecks that you want to solve.
Yeah. All right. I think that concludes, unless there is one question. Yes. Well, obviously, anybody who's interested in understanding products, either their own product or being part of a strategy, would probably need to dive into this. I think this is something that is happening to some extent on some products across KMD, but this is the first time that we try to write all the things down, all the questions that we potentially would ask, right, and have a structured approach to it. And we have dedicated people like me and Tommy helping a specific product, right? These things are hopefully going on in the company, but I think right now from the CTO office, this is one of the things that has a structured approach. And we are discussing to what extent this should be shared. Right now, there's a bandwidth problem, and it's only me and Tommy doing it right now. And it took at least one and a half month to just gather all the data, and then subsequently you want to identify and analyze the problem and have the dialogue with the product owner. And from there on, we can talk about implementing the changes that you're looking for, right? And if you want to do that across a company like KMD, where we have like close to 50, 60 different products, it's going to be a challenge, right? But sessions like this could be inspiration for a lot of teams to do something similar. Yeah.
Can I just add that you might actually identify a subset of this that you want to run. So for instance, you might identify that you only want to focus on the agile metrics because that's an area that you know you have some issues with. So
yeah. All right. That's it.
Okay.
Thank you.
Thank you very much, Tommy Andersen and Marcin Ciborowski. Okay, and we have 5 minutes break, so see you soon. Welcome back after the break. It's time for the next speech. It will be CarbonKey behind-the-scene experience for creating an app for carbon dioxide emission management. Our speaker is a full-stack developer working with Angular.NET, Azure, you know it, enthusiast of web technologies in KMD since 2021, privately father of 2 sons, in free time sailor and ice hockey player. He has gathered professional experience in Big 4 companies as a tax advisor specialist within the area of mergers and acquisition, a graduate of University of Warsaw Faculty of Law, and a scholar of Indiana University Maurer School of Law, US. Let's give a warm welcome to our colleague, Rafał Kelm.
Hi. My name is Rafał Kelm, as it was said. I'm a full-stack developer working in Angular and Microsoft technologies. Yeah, as it was also said, I'm a father of 2 sons, so if I only have time and it's not too much, I'm trying to sail and play ice hockey. Yeah, and it's a great opportunity. Thank you for this great opportunity to present in front of such an honorable audience. I'll be talking about CarbonKey, so our solution related to CO2 reduction. As you may know, there is some kind of an EU agenda currently related to CO2 reduction. We do have like currently two solutions which are created and developed in our company in so-called sustainable domain. So one of them is CarbonKey, which I'm talking today about. The second one is, and it relates to CO2 emission reduction. And the second one is the spend key, which is more related to the general assessment of the sustainability of some products which our clients buy. So, as you may know, the EU agenda is quite ambitious, and we are each member states of the European Union is obliged to follow some rules related to CO2 reduction. Denmark is very ambitious in their obligations, so it's about to reduce the CO2 emission by 70% till 2030. That means that, yeah, they have quite a lot to do. That's why the companies are working on different solutions related to CO2 accountancy. And one of these is the CarbonKey. So CarbonKey is aimed at making conscious choices of the products. When we buy, when municipalities, our clients, buy the products, we want them to be aware of what is the carbon footprint of different purchases. So we are also basing on this greenhouse gas protocol, which divides different emissions to like 3 scopes. This is, yeah, some kind of a general topic which probably we can dig deeper into, but maybe it's not for this presentations. Generally, it refers to some division of the CO2 emissions between the ones which are produced by the company and the entity the emissions which are produced by some other companies which are providing services for our company. And yeah, the third scope relates to other kind of emissions. Yeah, we are currently in the MVP phase with our product. So we are having our time frame for development of the MVP spans from 2022 until 2023, middle of the year, and we are currently focusing on the main functionalities of the CarbonKey. So yeah, I will show you some slides related to the product, to the app, but yeah, I want you to make sure that this is just from the UI and UX perspective still work in progress. So we are focusing more on the how the product works, not how it looks. Our clients are mainly the local municipalities in Denmark. There is 96 or so of these municipalities. These are kind of divisions of the Denmark, and they each day make some purchases in their entity. They have subordinated their entities like schools, kindergartens, other institutions, and all of those institutions are making some purchases. So it is very important from the Danish perspective to make these entities make conscious choices, taking into account the future goal of achieving the reduction at the rate of 70%. So going into the details of the CarbonKey, it actually consists of 3 modules currently. So the first module is mainly related to Power BI reports, which are gathering all the data from the municipalities related to purchases. And this is the module which actually can show us what is the current state of purchases, and shows us the historical data. And it differs from the other 2 modules, namely scenarios and initiatives, by this that these 2 latter modules are mainly related to what we can do with the current state. So, as I said, the first of these modules with which we plan our emissions is the scenarios module, and this is the most complex module, which allows for some kind of assessment. What can we do by reducing and making more purchases, on the other hand, of substitute products, and how it impacts the carbon footprint, CO2 emission. And on the other hand, we've got this second module, initiatives. So this is the module which actually allows for undertaking some actions. So the difference is that here we somehow calculate the impact, and on the other hand, in initiatives we are actually imposing some actions, and we can then track them in the CO2 account, so the Power BI module. So this is how it generally looks. And there is also one of the features which we are implementing right now. This is called templates. And the templates module will allow for some kind of creating these so-called templates. Why I came back to this slide is because we've got this company which is working in cooperation with us, which is called Vigamo, and they are the technical experts for the global climate change and those topics related to sustainable development. And they actually will be able to enter the application and create some profiled templates for different municipalities, for different clients, which are, the templates will be profiled for and customized to needs of the particular municipality. So this is also quite a nice feature because it takes out of expertise of our cooperating company Vigamo. So now I will shortly go through some slides of our UI. As I said, it's still a work in progress. We've got the entry page where we can choose between like 3 different modules, and this entry screen we can also choose when we've got sufficient permissions. We can choose between different municipalities, so we can have a look and get an overview at what is seen in the by different municipalities. There we've got this Power BI reports, which are pretty awesome. They look cool and they give us quite a important insight into the data. We can categorize emissions by scopes as it was shown previously. And also get some data which is related to purchases by the different municipalities. Then we've got this list of scenarios which we can choose from, and each scenario could have multiple products chosen. This is the section, and we can differentiate the adjustment and forecast of for how long will be simulate the making the simulation. We can also like make all the CRUD operations, so delete, edit, and also we can save them as initiatives, so these actions which we actually undertake, and then it will be fully integrated with Power BI report in the accounts. Then we've got this initiatives module. Actually, they pretty look the same. They differ with the columns. Here, when we are saying where we are looking at the initiatives, we can choose the priority, the current state. We've got the start date, end date. Currently, these are the whole years. We will be still implementing later the possibility to choose different periods monthly or even by date. And the last module is templates, as I said, and this will be mainly accessible by our technical experts. Then we can get into the calculation and simulation. We've got some graphs which are generated based on historical data. These red dots are meaning the actual expenses, actual emission points, the trend line, and the simulation we've got also the trend line and the simulation here. And we can then like check what are the numbers behind the graphs also to get the understanding of how we perform how we'll be performing in the next in next years. So this was this kind of a general presentation of the demo of the application. And where do we get the data from? So we've got the our company is having this big department which is called local government, and we are the municipalities are our clients. So we've got another application which is called spend analysis, and it's gathering pretty big quantity of data. So we, under agreements with the municipalities and the team which is developing this spend analysis, we got all the data for our purposes, and we are gathering this in our data hub and making some operations on that. So the data model is a pretty important part of our application, of course. So generally I wanted to say something about how the development of the application was progressing. So we are a team of like less than 10 people, and we are working. We've got the product owner, tech lead, one full stack developer, so me, two database developers, and other more business persons who are involved into the project. And of course, we are taking some kind of a support from our greater DIMA team. Here it must be said that we've got this DIMA team, so which stands for Data Information Management and Analytics inside the KMD. And we are, KMD is quite well organized, so they devoted some kind of a team which is called DIMA Platform Team, which is supporting us with different solutions that can be used in particular applications. So we are using also their experience to get things done faster. And so what it was like to develop this product. I mean, it started actually from trying to understand the data model. We are working in data-driven solutions, so the understanding of data model related to our products was pretty critical. And actually, we started with this product which we call CarbonKey at first, and then due to some kind of changes in priorities and the problem with our cooperation company, the company which we're cooperating with, not the Vigamo, but the other one, which is involved in the CarbonKey project, we had to move and switch to the CarbonKey product. But in the meantime, we already have taken some, got deeper into the data model analysis. So, and it was quite similar to what we were about to do in CarbonKey. So there was quite an agile approach to this product. And basically it started with some kind of discussion, brainstorm, which then resulted in a presentation which was created by our product owner and by our tech lead. And we started to develop first the framework application, and then generally the modules which I was showing. Of course, there were some problems during the iterations. One of them was related to different categorization of products. So in spend analysis, so the place where we get the data from, we use this UNSPC codes for categorization of products. On the other hand, in SpendKey, so in the product we also we are developing in the sustainability domain, we were having lots of databases were basing on the other categorizations, so the GPC categorization. So we had to map those. Yeah, and there were like different, of course, different tasks, different puzzles like this one, and yeah, we are getting through them during our development phase, which still continues. Also, I wanted to say something about generally about the infrastructure we use, but yeah, I won't go into much detail because yeah, this is quite a new product, so we don't want to disclose many things. But of course, what I can say that we are, as I said, KMD is quite a well-organized company. So we've got this DIMA platform team who is developing this kind of blueprint solution, which allows us to use Kubernetes and all the newest technologies. So we are using, of course, the microservices approach and containerizing our apps. We also have some database solutions and frameworks which are developed by KMD. So I must say that it might be very attractive from the perspective of the potential people who would like to join us in the development. And actually, it's great to work in this newest technologies stack, which is all the application. Thanks to that, it's always updated with all the newest stack. One thing at the end is that we are heading into the go live of MVP of CarbonKey. So it will be released at 30th of November this year, so in a couple of days. Actually, it seems this is quite one of the best solutions globally. We are talking with different companies, and we can see that their works are actually not so do not have such a progress with respect to this area. Of course, apart from Scandinavia, municipalities and other entities, we have also contacted some companies from Australia, for example, and they also look and quite eager to sign the contract with us and for MVP. So yeah, this is actually all about CarbonKey. Thank you very much. In case of any questions, please write me an email, or we can talk outside of the room if you want. And yeah, thank you very much.
Thank you, Rafał. I think all of us are looking forward to see what's going on in your project within a year from now. So thank you, and hopefully see you next year.
Yeah, thank you.
Okay, and now we have a 10 minutes break. So grab a cup of coffee and see you soon. Okay, welcome back. It is time for our last speech for the panel. It will be Ronin Network Bridge exploit worth over $600 million, biggest heist in crypto world till date. This hack analysis will be presented to you by our colleague, Senior SOC Specialist, KMD InfoSec, Web3 security enthusiast and bug bounty hunter at night, Konrad Gendłek-Skoczeń.
Hey, hi,
Give him
hello.
a warm welcome.
Hey, hi, hello. Good afternoon and welcome. So thanks for this intro. Before we start, maybe a few words about me. So generally, as my colleague said, I'm a senior SOC specialist at KMD Poland, and I specialize in cloud security solutions. Privately, I'm an OSINT passionate. I took part in a few Trace Labs investigations. For those of you who don't know it, Trace Labs is a non-profit Canadian organization that generally helps law enforcement around the world to find missing persons that were not available, that were not able to be found otherwise. I also made a number of submissions via the Europol Trace and Object initiative. It is a global initiative that helps find lost children. So that's that. Other side of me, I'm a Web3 passionate, mainly in the area of smart contract bug bounty on the platform of Immunify. And also I like to investigate DeFi hacks. Yeah, they're cool. And privately I'm a father of two and a husband. So yeah, that's me. So Web3 space in 2022 is doing great. Yeah, we had many funds stolen from many projects, bridges, many explained this year, so yeah, Web3 is doing great. Let's have a few big hits spoken about. For example, the cross-chain bridge of Wormhole, where the adversaries stole more or less $320 million. Of course, this is ETH price based on the conversion to US dollar in February. For example, next big hack was the Beanstalk Farms, an algorithmic stable coin that got attacked. It was August, and the adversary stole more or less $182 million. And that was August. In October, we had BSC Token Hub, BNB cross-chain bridge hacked, and the adversary stole more or less $127 million. So yeah, cool. Or not. And a rather fresh case, the FTX exchange that currently, I think, already collapsed exchange. I got, I think, hacked for roughly $340 million. But that's a very fresh case, so it's not that clear exactly what happened. But from this, what I know, the adversaries also got access to the internal FTX network, so they also managed to deploy malware with the latest update of the FTX mobile apps. So if you have it on your phone, delete it and use some anti-malware solution scanning on your phone. So yeah, a tip from me. But these were the hacks in 2022, so this year. And none of these was as big as the Ronin Network Bridge hack, so the king stays the same. But before I move into the hack, there are a few necessary explanations I need to do before we move on, as I want us to be on the same page. So the things I'll explain is the Axie Infinity and the friends, so generally stuff around Axie Infinity. I'll also explain the Ronin network, what it is, how it works, the Ronin bridge, what it is, how it works, and also what is an RPC node, so remote procedure call node. So let's start with the Sky Mavis. What's a Sky Mavis? It's a Vietnamese video game studio that is the creator of the Ronin network, Ronin bridge, and also one of the most successful Web3 games, that is the Axie Infinity. And the Axie Infinity is an NFT-based game in which the universe generally revolves around the creatures called Axies. And you can see on the picture on the upper right, these are these small creatures, they are called Axies. And generally, what is the game about? Players can collect these creatures, can battle with them, create kingdoms, lots of stuff. But generally, what is special about this game is it has its own player-based economy, yes, where people can generally trade, sell them, buy them, and generally do lots of stuff in the in-game ecosystem. What is also worth mentioning is the so-called Axie DAO, so decentralized autonomous organization that is created by players, and this is done via the governance token of AXS that is generally distributed to the players. And the main idea that the Sky Mavis company has is to have this token distributed in such a way that at the end of 2023, Sky Mavis won't have the most of the token in their possession. So it will become a true decentralized autonomous organization. So the game will be governed by the players and the community. So that was Axie Infinity. And as the game grew, the player base grew, the Ethereum mainnet started to be the bottleneck for further game development. That was because of the gas fees. Those of you who invested in crypto in the middle of 2021 know that the gas fees on Ethereum could be in $100 high or even more. And also, Ethereum mainnet was not the fastest, or even today is not the fastest one in terms of NFT gaming. So Sky Mavis needed to make a decision, and that is why they created the Ronin Network. That is generally an Ethereum sidechain. And what is a sidechain? A sidechain is a compatible to the Ethereum clone of the parent blockchain, so Ethereum clone, that supports transfer of funds between and to the parent. That also, this sidechain has its own block space, its own mechanism of creating blocks, and it has its own cryptocurrency. That is called RON, and it is generally used to pay for transaction on the Ronin network. Let's move on to the Ronin transaction flow. So generally, what is the Ronin transaction flow? It starts with a wallet, yes? The Ronin network, let me go back for a moment. The Ronin network, what's going on? Has its own wallet, and it is used generally as a medium to the Axie Infinity game. And the whole transaction flow starts with the wallet. And the Ronin network itself has a cool mechanism for users to be eligible to free transactions. So they don't have to pay for this transaction to be broadcasted. And generally, how it is done? Players can possess a special NFTs. Like for example, you can see this special Axie. You have a normal Axie and a Mystic Axie. And if you have in your wallet a Mystic Axie, you're eligible to some number of free transactions per month. Yes? So generally, what will happen is the wallet will see, okay, that you are eligible to free transactions. And what will happen is that the user, when the transaction is, let's say, created, will transfer, let's say, this transaction to the RPC node, so remote procedure call node. Then this node will broadcast the transaction onto the nodes. Then this transaction will be added to the mempool, the pool of transactions, and so on until the block creation, validation by the validators, and so on. While the process looks a little different in terms of, it looks the same for the paid transactions, but generally you have to pay for the transaction. So yeah, a little mix, but yeah. Now a little word about the Ronin consensus mechanism. As generally the Ronin network is a proof of authority blockchain, and generally at stake is the identity or the reputation of the validators. So unlike the proof of stake, where the stake is at stake, but while in the proof of authority blockchain, the reputation of the validators is at stake. And as you can see here, these little dudes with crowns, there were, in the time of hack, so March 2022, there were 9 validators only. If for those of you who don't know, that's a very low number. But yeah, in order to accept any transaction, 5 signatures are needed. Yes, and then the transaction will be accepted. Now another important topic, that is the Ronin network, the token deposit flow. And here we are coming close to the Ronin bridge and how it works. So generally the Ronin bridge consists of 3 elements. That is 2 smart contracts, one on each chain. As you can see, here's the Ronin chain, there's the Ethereum, and you have one gateway contract that is on Ethereum. So this is main chain gateway contract. You have the side chain gateway contract, so the smart contract on Ronin, and there is the off-chain worker, so the Ronin Bridge service that is generally responsible for synchronizing the events between 2 blockchains. Yes? Generally, the blockchains are usually done or created as a very hermetic system that is not used to talking with any other system or any other blockchain. They are closed, let's say. So that is the solution for them to talk to each other. But the deposit flow looks like that. A user submits his tokens, for example, I don't know, 4 units of ETH onto the main chain gateway contract. Yes, and then this contract locks up this 4, let's say, pieces of or units of ETH inside of it. Then the contract emits the deposit event into the off-chain Ronin Bridge worker. What happens then? If the number of validations, or number of signatures of the validators reaches the threshold of 5, then everything is cool. The Ronin Bridge will emit an acknowledged deposit event into the sidechain gateway contract. And what happens then? The so-called wrapped Ethereum in number of 4, yes, because we deposited 4 ETH, and here in the Ronin wallet we'll get 4 wrapped ETH. So this is a derivative of the same value from the Ethereum. Yes, so because we cannot transfer the ETH itself, yes, from the Ethereum blockchain, because it is locked there. It's kind of like escaped its own blockchain. So we'll have a derivative on the other blockchain with the same value, yes? Yeah, so this is the deposit flow. The withdrawal flow looks a little different, because if we want to withdraw our wrapped ETH into normal ETH on the Ethereum blockchain, then what happens? We transfer our wrapped ETH onto the sidechain gateway contract, and then the contract will emit the withdrawal event onto the Ronin Bridge. Then what happens? The Ronin Bridge responsibility is to collect signatures and to validate this whole transaction. And what happens then? These signatures will be submitted into the gateway contract, and if the threshold is met, so the 5 signatures, then the signature that the transaction that is signed will be, we can say, transferred to the for the user to submit it into the main chain gateway contract on Ethereum. And if everything is cool, process goes smoothly, then the ETH will be released onto the user, for example, MetaMask wallet. Easy, huh? Okay. And the last thing to explain is the RPC node. Simply put, it is a node, yes, that is running the same software as the validators, but not necessarily taking part in the whole consensus process. So it doesn't have to validate transactions, it has access to blockchain. That is the most important thing. And usually such a node is used as, for example, a private node by the decentralized applications. So they have their own private node on the blockchains that can be used, for example, for performance reasons, yes. Or sometimes as a relayer. As you remember, in the whole transaction flow on Ronin, when the wallet emits the transaction, it is being transferred onto the relayer, yes, of the RPC node that later broadcasts this whole transaction onto the other nodes. Yeah, sorry for that a little bit lengthy intro, but I wanted you all to be on the same page for the further understanding of the whole concept. That is the hack itself. So we start with the attack narrative. That is the November 2021. And as you can see on this graph on the upper right, this is the graph that shows that there is extreme spike in the user base of the Axie Infinity. If I read correctly, there were more or less 800,000 users at that time. There were more than 1 billion volume in terms of dollars, yeah, so extremely big number of dollars went through that Ronin chain, Axie Infinity, and so on. And also the number of transactions, let me take a peek, was I think more than 8 million. So very, very big spike in generally everything. And the infrastructure started to slow down, unfortunately. And when you play an NFT-based game, you don't like when the network is like slowing you down in terms of gameplay. That's a big no-no. And generally, the Sky Mavis, so the company needed some help. So what they did, they asked the Axie DAO, yes, because the 4 out of 9 validators were under control of Sky Mavis, but 5 others were in the control of Axie DAO. So generally, the community was setting up and having control over these validators, these 5 out of 9. And generally, Sky Mavis asked Axie DAO if they could help. And the community voted, yes, we help. So what happened? There was a new RPC node set up that was supposed to ease off the transaction costs. And through that RPC node, generally the Sky Mavis validators were whitelisted. And the Sky Mavis validators were able to sign transactions on behalf of Axie DAO. Yes? So generally they had more, you can say more keys or more signature power, let's call it, than they usually had. And as I wrote here, setup was discontinued a month later, not necessarily, because the eligibility to sign transactions was still, we can say, alive, even after that. So keep that at the end of your mind, as we will now transfer to the preludium of the whole hack. That is somewhere in March. There was no documentation or anything when exactly, but we know March 2022, when one of the senior Sky Mavis engineers got a message on LinkedIn, where he got a proposition with such a ridiculous compensation package, of course in positive terms, that he just could not refuse. So he took part in the whole recruitment process. He went through a series of talks. He went through a series of HR traps or tasks, however you call it. And he got a message that he got accepted. Everything is cool. Here is your final offer. He got a final offer via PDF on a private message on LinkedIn. He opened it. And unfortunately for him and Sky Mavis, there was also another nasty surprise inside. There was a spyware. For those of you who don't know what spyware is, this is generally a malicious software that is supposed to track the user behavior. Yes, and the user doesn't know about it. So for example, I don't know, you visit some website and the guys that control this spyware know about it. They know your credentials and stuff. Generally very, very bad program. Yeah, so we move now to the crescendo of the whole attack. Via implanted spyware on the senior Sky Mavis engineer, the adversaries were able to hijack the whole credentials of this engineer, his network access to Sky Mavis systems, and unfortunately also to the most critical parts of the Ronin network. I don't mean the blockchain, but I mean the infrastructure of the Sky Mavis as a company. And exactly what I mean is that in one network share, in one storage space, they held all the Sky Mavis validator private keys. Yeah, that was not cool. But they got it. So only four. 4 is not enough to forge a transaction. But I'm now referring to the back of your head. Do you remember the RPC node and this whole setup that was not discontinued really? Yeah, there he is. Unfortunately, as this RPC node was a normal, we can say, server that was doing some functions, and the adversaries were not stupid. They found, this is just my theory, as unfortunately Sky Mavis nor anybody were able to dig what exactly happened, but my guess is that they found some classic OWASP top 10 vulnerability. But they were able to get a foothold over in the RPC node. They were able to take over this machine. And generally what they got is the Axie DAO validator private key. Yeah, so from my perspective, game over. As they had 5 out of 9 validator private keys, so more than 50%. So they were able to forge and sign transactions via the stolen private keys. So that is the address that was one of the most popular and most viewed on Etherscan during March of 2022. For those of you who are not that much into crypto, at Etherscan is, we can say, a site, or we can say a block explorer through which you can track various contracts, transactions on the Ethereum blockchain. So because in blockchain everything is public, yeah. So that address was mostly viewed on Etherscan during that time. So what they did, they signed and they forged and signed 2 transactions. One was the transfer for 25 million USDC from Ronin Bridge. The second one was the transaction for 173,600 ETH from Ronin Bridge. So in total, yeah, I know the title of the presentation lies a little bit because I wrote 600 while it's 625. Yeah, sorry. Where they stole $625 million in value. Yeah, that is based on price of ETH during March of 2022. Yeah, and to get a little bit more technical, I will show you these transactions as I found them via the so-called token flow. There are very many tools to we can say take the transaction apart into the code, let's say. So this is exactly the transaction hash. There is, yeah, I lied to you again. It's 25.5 million. Sorry, I hope that you'll forgive me. That is the address of the attackers, and here are the 5 validator signatures. Let's say, as you can see, there's the main chain validator method that checks if the address is validator. Plus, there is here it is. No, it's not. It's cut. Whatever. Later here there's the signature. But anyway, we move to the biggest one as we go to the ETH that was stolen. Yeah, 173,600 ETH stolen. There is the attacker's address. Can we see the signatures? Nah, it's cut, whatever. Yeah, but you can see 5 signatures that were, we can say, forged, as these guys stole the private keys, as I said. Yeah, we go to the aftermath. Because apart from the gargantuan volume of funds stolen, the gargantuan mistake from the Sky Mavis team was that they found out about the hack 1 week later. Yeah, because apparently one user wanted to withdraw, I guess, 5,000 ETH, if I'm not mistaken, and he could not. Because do you remember, you exchange your ETH for wrapped ETH to get your mind a little bit more at ease. I will explain it via another example how the old banks used to work. So generally, for example, you have $100. Yeah, you have a bill, $100. You go to the bank, you give them your cash, and you get a certificate back that says that this and this person is eligible to $100. Cool. You have your certificate in your pocket. Cool. And when you want to get your money back, you go to the bank, you take the certificate there, and you get your money back. Yes, because you had a certificate and they gave you your cash back because you were eligible to withdraw it. Another scenario, a little bit more connected to the hack. Let's say that, okay, you still have your certificate for $100. Yeah, and then the bank gets robbed. Yeah, you have your certificate. You're still eligible to withdraw $100. But when you go to the bank, there's no money. Yes, but you still have $100 in certificate. Yeah. But if the bank is robbed, it's worthless. So that was the same situation here. So people had their wrapped ETH, but there was no ETH to exchange it for. Yeah, that was the situation. And they found out about it 1 week later. Pretty lame, if I must say. So another big question is, who did that? Yeah. Thanks to our friends from FBI, unfortunately they were not keen to share any documentation from their findings. But what they found out is that the group that was behind this whole hack was our favorite friends from North Korea, the Lazarus group. And this can be found in the US Department of the Treasury site, as you can see, North Korea designation update. And let me make a little zoom. The Lazarus group, aka Ipleworm, blah, 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 blah. And here is digital currency address ETH, and here's the wallet address from the Ethereum blockchain. And generally what it means that this address is sanctioned, it cannot be traded with, and generally is blocked and banned into the shadow realm. So yeah, that was the site of the US Department of the Treasury. And let's move on to another cool trivia, the free marketing. And as I told you, in blockchain, everything is public. Transactions, wallets, everything. So generally, as in March, people started to notice that there was a big hack. They know who did that. Yes. So they started to observe transactions coming in, coming out, because people were keen to know what these guys will do with the money. Because I don't know how about you, but I would have very big difficulties to launder 625 million. Yeah, but coming back to the topic, free marketing. Everything is public. We can see all the transactions coming in. Some people were clever. Maybe they were Polish. I don't know. But they wanted to harness the power of the crowd and people looking at this address. And they made some, we can say, deposits onto this address. This is probably a few dollars, but they appeared here. Yes, because this is the tool called breadcrumbs, for which you can generally observe what addresses and in what amount deposit and withdraw from the specific address. So in the center you have this Lazarus Group Axie Infinity hack address, and you can see who exactly did the deposit. So there was somebody chrisdaddy.eth or Sandra.eth. So yeah, these guys were clever, or girls, sorry. Another big question: where is the cash? Some funds, for those of you who don't know what a Tornado Cash router is, or generally what Tornado Cash is, this is, we can say, a solution to break the mapping of the cryptocurrency to your wallet. Because as you can track generally the funds that flow in and out from wallets, this is not too private, because if you, for example, tie a person to a wallet, you know exactly what were his financial operations on blockchain. And what this solution does, it completely breaks this mapping, so the cryptocurrency is no longer traceable on blockchain. And some money went to the Tornado Cash router, so became untraceable, and some were transferred among many minor wallets, as you can see on the slide: Ronin Bridge Exploiter 3, Ronin Bridge Exploiter 8. So generally, the people started to map or track or tag these addresses that were connected with the withdrawals from this, we can say, hacker address. Yeah. Let me speed up a little. Also, thanks to our friends from Mistrack that generally tracked this behavior, some funds were transferred into the centralized exchanges like Huobi, FTX, now it's collapsed, so, or Crypto.com. This is pretty strange, because centralized exchanges are known for their KYC policies. What is that? This is the Know Your Customer policy. So generally, before you open an account, you need to make a selfie, and you need to make a photo or a scan of your personal ID, so they know exactly who you are. So there is no hacking on your personal account on Huobi, because next day FBI or somebody else from the authorities will knock on your door. And by knocking, I know what you mean. You know what I mean. So my guess is that they had some accounts simply hijacked from normal people. Yeah. So they hacked their accounts, and then they could launder money. Plus, anyway, if even their personal identities would leak, who would get them in North Korea? Yeah. So summing up, what went wrong? First things first, the validator centralization by Sky Mavis. And this would not be that bad, even if they had still 4 out of 9 validators, but the private keys would be distributed among their whole network, plus another security solutions or procedures would be implemented, that would be fine. Yes, but they were in single place, so very bad stuff. Neglection of temporary solution. Yeah, so I mean this, that they could sign the transactions via the Axie DAO validator, and they forgot about it. Complete lack of monitoring. Yeah, how can you not see being robbed out of 625 million? And also excessive permissions allowing access to validator keys. So if one engineer could access all four of them, I think the security controls failed big time here. So coming to the end, what they improved since then, the validator count increased to 21, a long-term goal 100. A little star from me, I hope that the private keys are now distributed. Also, they started a bug bounty program with bounty over 1 million. So if we have any fellow white hats here, you can earn some good cash. Also, Sky Mavis raised 150 million in April to reimburse the users. At least it's something. So yeah, that was it. Thank you very much. I hope you're not sleeping and you had a, I don't know, that was not too scary.
Thank you very much, Konrad Gędłek-Skoczeń. Yeah, this was really, really entertaining. I really look forward to hearing again from Konrad. So, this is the end of track 2, but we'll still have one more keynote speaker that will hold in the other room. So we'll have 10 minutes break. So thank you for now and see you soon.